Hello everyone, this will be our last tutorial for transformations. Okay, so this tutorial will cover dilations, and a dilation is just an enlargement or reduction of a figure using a scale factor. The pre-image and the image are similar, and the ratio of the new image over the old image is the definition of a scale factor. Okay, so this applies if we're given either side lengths or coordinates. Okay, so we can use this the scale factor on both, even either side lengths or coordinates. Now this one here, if the scale factor is less than 1, we are talking about a reduction. So this is a reduction. Okay, if the scale factor is equal to 1, that means the figures or coordinates are congruent. Well, especially the figures are congruent. If the scale factor is greater than 1, then this is an enlargement. Okay, so let's go right into an example so that you can start understanding this here. So notice that this is the A, and that's the A prime, D and D prime. So that means this is the old figure and this is the new figure. Okay, so to find the scale factor, we do new over old. So I'm going to take this side and I'm going to find the scale factor. So SF stands for scale factor. So it's new over old. So that's 30 over 5. 30 over 5 reduces to 6. And also 18 over 3. So now it's this one here and that 3. So that's 18 over 3 also reduces to 6. So the scale factor is equal to 6, which is greater than 1. Okay, so that means we're talking about an enlargement. Because the scale factor is greater than 1, so this is an enlargement. And that should be also obvious from the diagram. Okay, so that's the first example. The second example, we're given coordinates. Okay, so we do the same thing. We're going to find the scale factor, and we're going to start with the x values. So x, I'm going to take, this is the old, because that's A and this is A prime, so this is the old coordinates, and this is these are the new coordinates. So new over old. So for x, 4 over 12, and that reduces to 1/3. And then for y, it's 8 over 24, and that also reduces to 1/3. Okay, now let's go back. If the scale factor is less than 1, then we are talking about a reduction. So we know the scale factor is 1/3, which is less than 1, so this is a reduction. Okay, so that's a reduction. Now the last example, this is the last example I'm going to give you for this tutorial. So what if, again, we're given coordinates, and these are the coordinates of a triangle JMA. So in the coordinates, we're going to use a scale factor 1/2 on each one of the coordinates, and we are asked to state if it's an enlargement or reduction. So let's find the coordinates of J prime. So J prime, we're going to take half of J, in this case -6 and 2, and half of -6 is -3, and half of 2 is 1. So these are now the coordinates of J prime. Now do the same with M prime. Okay, so M prime, we take half of the coordinates of M, so half of 9 and half of 6, and that's half of 9 is 4.5 and half of 6 is 3. And then we do the same with the coordinates for A prime. So A prime, we take half of 1, coordinates of A, 1 and -3, and this becomes half of 1 is 0.5 or 1/2, and half of 3 is negative 1.5 or negative 3/2. Either way is correct. Okay, so as you can see, this went from negative 6 to negative 3. This one went for 2 to 1, from 2 to 1s, and then this one went from 9 to 4.5 and 6 to 3. And the scale factor is 1/2. So we know, because that's what we're given, SF equals 1/2. So as soon as you see this, this is less than 1. So we are talking about a reduction. Okay? So this is a reduction. And these are the coordinates of the new triangle J prime, M prime, A prime. Okay, so that's all for now. I'll see you guys in the classroom. Bye-bye.